How is a metal alloyed? An alloy is a mixture of atoms of different elements in which the main component is a metal, known as the solvent metal. Because the alloy is in effect a solid solution, the added materials are known as solutes, a term that is analogous to substances that dissolve in water. An alloy such as mild steel is known as binary alloy because it contains only iron and carbon. Many of the alloys used to make platinum point alloys are known as ternary, quaternary, quinary alloys, so named because of the number of different substances they contain. State changes and alloying. Alloying can only occur when the solvent metal is in a liquid state. In terms of particles, what has happened is the metallic bonds which exist between the atoms have been weakened such that they can slip and slide over each other. When a pure metal cools, it will solidify, and this means that the bonds between the atoms will reform. Normally the metal itself is reshaped or casted as required or needed. In precious metal extraction, the metal will be shaped into casts known as ingots. To change the properties of the metal, the solute particles must be added in the liquid state. One reason for alloying is to increase the strength of the metal. This is achieved because different atoms have different sizes. So, when a solute substance is added in the exact percentage required and thoroughly mixed into the molten metal, the arrangement of atoms changes. This change in arrangement changes the strength and mechanical properties of the alloy as compared to its original state. Mixing molten substances when metals are mixed. The process is known as atom exchange. Atom exchange tends to happen between atoms of similar sizes, and there is a substitution of one type of atom for another. Such alloys are also called substitution alloys. When atoms are of different sizes, the smaller atoms cannot replace the larger ones, and so they become trapped inside the arrangement of atoms in the solvent metal. Many point alloys fall into this category. This increases their strength and durability and makes them eminently suitable for alloying wheels. Solidus and liquidus. PT starts to melt at 1768 degrees. This is known as its solidus temperature. For a given mass of PT, heat will continue to be absorbed until all the bonds between every PT atom have been weakened. Only once this has occurred, the liquid's temperature, will the quantity of PT be completely melted, and the temperature continue to rise. It is in this liquidus state that the arrangement of atoms can be controlled and altered. It is important to state that engineers only know about the various properties by precise experiment. In other words, trial and error, which, of course, also means slogging until the desired result is obtained. For example, a binary PT alloy will have different properties from a quinary PT alloy. This is because different atoms of different sizes have organized themselves in the molten solution according to their different physical properties. A further factor is the rate of cooling. If the molten solution is allowed to cool rapidly, then the relative sizes of each crystal formed in the alloy will be smaller than if allowed to cool slowly. In addition, a faster rate of cooling allows more of the individual types of solvent atoms to aggregate within the solvent metal matrix. Alloying is a precise and complex undertaking requiring detailed knowledge of physical and chemical properties of the substances that make up the alloy.